So similarly, tan of 90 plus theta, you can prove that. Sine of tan of 90 plus theta, what we can write it as? Sine of 90 plus theta by cos of 90 plus theta. When you take the ratio, you end up with minus cot theta. So we have finally derived some of the most essential things. Sine of minus theta, we ended up minus sine theta. Cos of minus theta, already we have derived it. Just I'm summarizing. Tan of minus theta minus tan theta. Sine of 90 minus theta, we got cos theta. Cos of 90 minus sine theta. Tan of 90 minus cos theta. Then sine of 90 plus theta, cos theta. Cos of 90 plus theta minus sine theta. Similarly, we can try for this thing. You try this. These identities you tried. I have shown these things. You try these things. Sine of 180 minus theta, what it will be. The similar approach you have to put it. So finally, so in the quadrants, what we can add is like here. So in this, all are positive. You take this one, sine 30, sine 30 degrees, sine 15, sine 30, cos 30. That's one. Any of the angles like tan 30, tan 45, tan 60, all are positive. What about here in the second quadrant? Sine is positive, cosecant is positive. The remaining other things are negative. So only sine is positive. In the third quadrant, tan theta is positive, and its reciprocal cot theta is positive. Remaining all are negative. In the fourth quadrant, cos theta is positive. So therefore, we just call all are positive. Your sine only positive, your tan only positive, your cos only positive. So all silver teacups. I think this will be enough. So in which quadrant, which will be positive? In first quadrant, all are positive. Second quadrant, only sine is positive. Third quadrant, only tan is positive. Fourth quadrant, only cos is positive. And this is what we can conclude here. Let's take the identities. Already we know sine square theta plus cos square theta equal to 1. Just I wrote it. And secant square theta minus tan square theta, or secant square x minus tan square equal to 1. Cosecant square x by cot square x equal to 1. These are the identities. Already we have proved it in the previous class. Let me go for it. Sine 2x. How sine 2x equal to 2 sine x cos x. This is I'm trying to prove the identity. We know sine of a plus b formula. Sine x plus sine 2x, can I write it as sine x plus x? Sine of x plus x, this angle. Let me apply the compound angle formula. Sine a plus b, sine a cos b, cos a sine b. Then sine x cos x sine x will become 2 sine x cos x. So therefore sine 2x, we can write it as 2 sine x cos x. Very, very essential thing, which will be widely will be using in the physics. And then cos 2x, how much it will be? Cos 2x will be, we know, cos square x minus sine square x. Sine square x, what you can write? 1 minus cos square x. 1 minus cos square x. Then this, after expanding this bracket, will end up 2 cos square x minus 1. Or let me send this minus 1 onto the LHS. So 1 plus cos 2x equal to 2 cos square x. So therefore, what is the expansion of cos square x? Should be equal to 1 plus cos 2x by 2. I can also write cos square x as 1 plus cos 2x. There's a one identity. There's another thing is what I brought it. We'll give the number 7. Let this be it. Similarly, sine square x, I'll write it as 1 minus cos square x. Cos square x, just now we derived 1 plus cos 2x by 2. Substitute here. 1 minus 1 by 2 minus cos 2x. Solving this, sine square x equal to how much? 1 minus cos 2x by 2. Sine square x equal to 1 minus cos 2x by 2. Cos square x is 1 plus cos 2x by 2. All these are identities which are going to help us a lot in our physics. Let me go. So now tan 2x. What is the formula of tan 2x? Tan 2x, I can write tan of x plus x. Then tan a plus tan b formula. Tan a plus tan b 1 minus tan a tan b. Then this will be 2 tan x by 1 minus tan square x. Okay, the conversions, quite easy, no? Here. Then transformation of sums or difference into products. We know sine of a plus b equals sine a cos b plus cos a sine b. Sine of a minus b equals sine a cos b minus cos a sine b. Let me add up these two here. Sine of a plus b plus sine of a minus b. Then the addition of these two sine a cos b. These two will cancel out, no? When you add up these two equations, we'll end up 2 sine a cos b. Let me assume things. Let a plus b equal to c. Let a minus b equal to d. Then let me solve this two. So a plus b equal to c, a minus b equal to c. Let me add up this. So 2a plus 0 equal to c plus d. So therefore, what is value of a should be equal to c plus d by 2. Then similarly, what is value of b? C minus d by 2. Let me substitute those things here. A plus b is how much? C. A minus b is how much? D. 2 sine. So in place of a, what you can write? C plus d by 2. In place of b as c minus d by 2. So therefore, sine c plus sine d. The sum, we are converting that into products here. So sine c plus sine d is equal to 2 sine c plus d by 2 cos c minus d by 2. Converting the sum to the products. Similarly, we have the other thing. So same method you try to apply and then try to work out these things. Sin c minus sin d formula. 2 cos c plus d by 2 sin c minus d by 2. Cos of c, cos c plus cos d formula. Again 2 cos c plus d by 2 cos c minus d by 2. Cos c minus cos d again. And these are conversions what we have made here. Okay, now we'll go for certain angles. So what will be the value of sine 15? How to derive? So we do take help of compound angles like sine 15 degrees. Sine of, can we write it as 45 minus 30? This will be better, no? So do we know sine 45, sine 30 values? Yes, we know. So this will, let me expand now. Sine A minus sine B. Sine A cos B minus cos A sine B. Sine 45 1 by root 2. Cos 30 root 3 by 2. Cos 45 1 by root 2. Sine 30 1 by 2. Then this will become sine 15 how much? Root 3 minus 1 by 2 root 2. We can also do like this. Sine 15. Sine 60 minus sine 60 degree minus 45. Sine of 60 degree minus 45 degree. Expand sine of A minus B formula. Sine A cos B cos A sine B. Again, we'll end up the same thing, no? Either way. 15 degrees, you can write it as 45 minus 30 or 60 minus 45. Let's come for here. Cos 15 degrees. Cos 15 is equal to cos 45 minus 30. Cos of 45 degrees minus 30. Cos A minus B form. Cos of A minus B formula. Cos A cos B plus sin A sin B. Cos 45 1 by root 2. Cos 30 root 3 by 2. Sin 45 1 by root 2. Sin 30 1 by 2. Solving this will end up here. Then sin 75. 45 plus 30 degrees. Sin 45 cos 30. Expansion sin of A plus B formula. Applying this will end up these equations. All these things you are going to get revised in trigonometry, but in physics we need all these elementary things. That's why I'm just trying to brush up all these ideas. Similarly, tan 75, we'll check it. Tan 75, I can write it as tan of 45 plus 30 degrees. So tan 45 plus tan 45. So the formula tan A plus tan B, 1 minus tan A tan B. Tan 45 plus tan 30, 1 minus tan 45 tan 30. Tan 45, 1, tan 30, 1 by root 3. 1 minus 1, 1 by root 3. Solving this will end up root 3 plus 1 by root 3 minus 1. The value. Then sine of 120 degrees. Sine 60 plus 60. 120, I'll write it, I'll break up 60 degrees plus 60 degrees. Now, this one. Sine of A plus B, sine A cos B plus cos A sine B. Let's substitute this value. Sine 60 root 3 by 2, cos 60 1 by 2, cos 60 1 by 2, sine 60 root 3 by 2. Solving will end up here. Similarly, cos of 120, cos A plus B formula. Cos A cos B minus sine A sine B. Cos 60 1 by 2, cos 60 1 by 2. This sine 60 is root 3 by 2, root 3 by 2. Root 3 into root 3 will be 3, 3 by 4. So 1 by 4 minus 3 by 4 minus 1 by 2. So see now, sine of 120 degrees, root 3 by 2. I said no, like a sine theta will be positive in the second quadrant. Remaining all are negative. Now you can ask questions. You wrote something very, here sine theta positive, cos theta negative. Sine 120 we got value which was positive. Cos 120 was negative. That's what I was insisting here. Cos 60 will be positive. Sine 60 will be positive. So all are positive if the theta lies between 0 and 90. If theta lies between 90 and 180, sine will be positive. Remaining all other angles, sine of all other angles will be negative. That's what I am insisting there. So, sir, how to write these things is means come back here. Okay. So nothing is for granted here. Sine of 120 degree. Why it will be positive? We have here proof. Cos 120. Sir, why cos is negative in the second quadrant? We have a proof. Check it here. Okay, now see, we'll go for angle 105 degrees. So 120 minus 15. We can write it in this way also. So sine 120, so, sine A minus B formula, sine A cos B minus cos A sine B. Sine 120 root 3 by 2. Okay, this one. Just now we derived, no? Root 3 by 2. Cos 15 we have derived, no? Here. Root 3 plus 1 by 2 root 2. Let me substitute that here. Root 3 plus 1 by 2 root 2. Then cos 120 minus 1 by 2. Sine 15 root 3 minus 1 by 2 root 2. Here denominator 4 root 2 will come. Here also denominator 4 root 2. So this will be root 3 into root 3 plus 1. Here root 3 minus 1. Let me expand this. 1 by 4 root 2 I'll take common. So root 3 into root 3 will be 3. Root 3 into 1 will be root 3. Root 3 minus 1. So this will end up with 3 minus 1 will be 2. So 2 plus 2 root 3 by 4 root 2. Or take 2 common. Then 1 plus root 3 by 2 root 2. Or root 3 plus 1 by 2 root 2. This is the value of sine 105. Sine 150 degrees. Sine 180 minus 30 degrees. So applying sine A cos sine A minus B formula. Sine 180 degrees must be 0. Sine 180 will be 0. Cos 30 root 3 by 2. Cos 180 is minus 1. Sine 30 is 1 by 2. So sine 150 degrees will be 1 by 2. Cos 150 again, cos A minus B formula, we applied it. So these are all the some identities what we proved. Okay, we'll go for few more left over. Let me finish off, then we'll say goodbye to this topic. Because if not like I'm not math teacher, so let's not spend more and more time in these things. Let me go for other identities, like a tan 2a, how much it will be. Okay, already tan 2a got over, no? Like a sine 2a in terms of tan 2a. We will try to derive. Few more are the last. I think when your mathematics teachers, you will be in a better position. Let's a bit some help I made it here. 2 sine A cos A. As you know, sine of 2 theta equal to sine theta cos theta. Then let me adjust this. Sine A by cos A. All divided by it will become 2 sine A cos A only. I divide and multiply by cos A here. So then this will become 2 tan A by 1 by cos square A. 1 by cos secant A, what we can write it as 1 by cos A. So therefore this will become secant square A. And secant square A, what we can write it as 1 minus tan square A. We know secant square A minus tan square A equal to 1. sorry, tan square A minus secant square A. And there's one identity is there, no? Secant square A plus tan square A is equal to 1. Well, I wrote it, I forgot. Yeah. Using this, we can replace this one. So sine 2A in terms of tan. Somewhere will be useful. Now, similarly, cos 2A, can we bring in terms of anything? So cos 2A. We know this is cos square A minus sine square A. Can we write it as cos square A? This I'll hold it by 1. Cos square A minus sine square A. 1, what we can write? Cos square A plus sine square A. Let me take cos square A common. So 1 minus sine square A by cos square A. 1 plus cos square A. So therefore cos 2A should be equal to 1 minus tan square A, 1 plus tan square A. So that there's a relation between cos 2A and tan A, sin 2A and tan A. Sir, what is the use of this in physics? Maybe, not like very much useful like other trigonometric identities. Let me last the sin 3A will, what is the expansion of the sin 3A? What we can write it as sin 2A, sin of 2A plus C. Then this will become sin 2A cos A plus sin A. Then sin 2A, further the expansion of this will be 2 sin A cos A. Cos 2A, I'll write it as 1 minus 2 sin square A into this is sin A. Okay, I think we have done some replacement of like this. Then sin 2A is 2 sin A cos A. So then this will become equal to this 2, I think 2 sin A will I'll expand further. So 2 sin A cos square A. This will become 1 minus, as usual, we'll keep it 1 minus 2 sin square A sin A. Cos square A, I'll write it as 1 minus sin square A. So 2 sin A, 1 minus sin square A is there. So 2 sin A. What we wanted, we will just wanted some division. Okay, let me expand further. This will become 2 sin cube A, then sin A minus 2 sin cube A. So this will become 3 sin A 4 sin cube A. Will be useful in some year-ended calculations. That's why I just picked up this one. Similarly, we'll explore cos 3A. Cos 3A will be equal to cos of 2A plus C. Again, the expansion of cos, this will be cos 2A cos A, sin 2A, sin A. Cos 2A value, cos 2A we can write it as 2 cos square A minus 1 into cos A. Sin 2A, 2 sin A cos A, and this is sin A. So 2 cos cube A minus cos A, 2 sin square A, 2 cos A sin square A. So this will become 2 cos cube A cos A. Sin square A we can write it as 1 minus cos square A. So 2 cos cube A minus cos A will be 2 cos A plus 2 cos cube A. So this will become 4 cos cube A minus 3 cos A. The last identity, tan 3A. So tan 2A plus A. Tan A plus B formula will apply it. Then this will become tan of 2A plus tan A 1 minus tan 2A into tan A. Tan 2A, 2 tan square A or 2 tan A by 1 minus tan square A. This is tan A. This will be 1 minus 2 tan A by into tan A. Okay, this simplifying all will end up as 3 tan A minus tan cube A 1 minus 3 tan square A. Okay, this